Problem number 68, page 691, acid-base chemistry. This problem asks us to calculate the hydrogen ion concentration and pH of a 0.025 molar solution of formic acid. We are told that the acid dissociation constant, or the Ka value, is 1.8 times 10 to the negative fourth. Formic acid, with the formula HCO2H, is a weak acid. It's only going to partially dissociate, meaning it's going to come into equilibrium with its ionic components. Because weak acids achieve a state of equilibrium, we're going to need to set up an ice box to figure out the equilibrium concentrations. Here's the completed icebox table with initial concentration, change of concentration, and equilibrium concentration written. I've written the Ka expression for this reaction. We know the Ka value, it's given in the problem, or we could look it up in the text. We know that these are the equilibrium concentrations that we can substitute into this Ka expression, solve for X, and then if we know X, we can determine the hydrogen ion concentration. Here I've substituted in the Ka value given and the equilibrium concentrations. Substituting in, solving for X, putting X into our equilibrium concentrations, we can determine that the hydrogen ion concentration is 2.1 times 10 to the negative third. Since the problem asked us to calculate the hydrogen ion concentration, which we already have, and the pH, we're going to use the pH equation, substitute in the hydrogen ion concentration to determine the pH. After doing that, you will determine that the pH is 2.7, hydrogen ion concentration 2.1 times 10 to the negative third. Those are the answers to the problem. Any questions?